they give you with a number, we have 4 possibilities. Now these are just sketches. You're not going to be doing sketches. You're going to do tables. Okay. Now an exponential function will either look like this, like that, like that, or like that. So let's look at this a second. Now, as b or as x increases, the only way our number can get bigger is if b is greater than 1, because you're multiplying by b repeatedly, right? So if I'm multiplying by half repeatedly, things are going to get smaller. So these graphs indicate that b is greater than 1. Okay, and the only way that this can be positive, like this, on the top side of your x-axis. For this graph, a is positive, and for this graph, a is negative. Because what's going to happen is I'm going to apply my exponent to b, and then I'm going to turn around and multiply by a negative number. So it's always going to make it negative, right? Okay. Now, it's not to say that every single exponential graph, these do not happen to touch the x-axis. And for our purposes, those are the only ones we're going to deal with. They are not going to cross the x-axis. They'll get very, very close to the x-axis, and then quickly get far away. Now, if you were to add or subtract from this, that would shift it up or down. So you might cross the x-axis once, okay? But we're not going to worry about those at this point. But if it's increasing as we go positive in the on the x-axis, if it's getting farther away, let's put it that way, then b would have to be greater than 1. Okay? The negative in front takes what you would have had and flips it over the x-axis, is what happens.
For the other one, like there's 2 graphs, is the top one negative and the bottom one positive?
Yes. So here, this would be a is positive, and here a is negative, because it does the same thing that it did over here. The difference is that with this one, as x gets bigger, our y value is getting smaller and smaller. So that would be like multiplying by less than 1. Okay? We're not multiplying. B is never going to be negative. But in this case, b is greater than 0 and less than 1. So basically, b is a fraction. Fraction less than 1, not improper. A good way to think about this, and sometimes this helps visually for people to understand, half is less than 1, right? Okay. So if I take a sheet of paper and I take half of it, then what remains is smaller, yes? And if I go half again, now I have a fourth of what I had before. And half again would be an eighth. right? And I can keep taking half. Now it's going to be hard for me to keep folding it, but theoretically, as long as you're taking half of something, you still have something, right?
Yeah.
Even if that something is teeny tiny microscopically small, it's still not going to become 0, right? And it's not going to be negative because I'm taking half. Half of something is still something, which is what this illustrates. Okay? So whatever you start with, if you just keep taking half of it, it's going to get closer and closer to 0, but it's never going to hit 0. Does that make sense? And that's as long as it's less than 1. I could take 2/3 of something and I'd have the same effect. It's going to get smaller and smaller, but never, not going to disappear. Right? Look at. Okay. So this is when we're multiplying by something bigger than 1, and this is between 0 and 1. So this is going to help you because that should tell you what your graph should look like anyways. So the rest of it is just plugging in and picking our values. So here's the first one we're going to look at. Okay, so you should always go with 0. And if I go with 0, this is going to be 1, right? Yes?
Mm-hmm.
So let's put that in the center of our table. So if I go with 0, I have 3 times 2 to the 0. That's going to be 1, so my output should be A. So 0A will always be one of my points. Okay, so A is 3. Now from there, I should see what's happening on either side of that y-axis. Yes?
Mm-hmm.
So if I do 1, then I have 3 times 2 to the first power, which is just 3 times 2, or 6. So that's not going to be a bad point to graph, right? 1, 6. Okay, let's check out -1 because you should have something to the left as well. So we have 3 times 2 to the -1. And you're going to move that under the A. So this would be 3 over 2. Now, at this point, it's up to you. If you don't know what 3/2 is, you want to turn that to a decimal. That's 1.5. For the graphing, you can do that. Okay, now these are the 3 that we have. You can decide from there if you need something further to the negative or further to the positive to give you a good picture of your graph. Maybe you just want to graph those 3 and see what it looks like. Okay, but if it's not a good picture of your graph, you should add another x value. Does that make sense? So let's see what this looks like. Now, just so you're not wasting a lot of paper, both of these are positive. Are you going to need anything on the lower side beneath your x-axis? No, I wouldn't draw a big long line underneath because you're not going to be graphing on the bottom side. Just like if A is negative, you're not going to be graphing on the top side. So when we graph this, you can consider that. I would still show the origin. So I have -1 and 1.5, 0, 3, 1, 1, 2, 3, 4, 5, 6. Okay, now I'd say on this side of my graph, that's pretty good. I might go 1 more negative value, okay, because this is not a very big piece of my graph. So let's add another. You can do top or bottom, really doesn't matter. We'll do it down here, -2. So we're going to add in that negative 2. So this would be 3 times 2 to the negative 2. What do we do with this again?
Put the 3 on the bottom.
Put it,
I mean the 2.
yeah, so this would be 3 over 2 squared, which is 3/4. Okay. 0.75. So negative 2 and 3/4 would be about there. And that, you're starting to see the curve now, right? Because these should not be lines. These are not linear. Now keep in mind, they go forever in both directions. So we should have double arrows on these. And this one is going to get very, very close to the x-axis but not cross it. So you can start by connecting those but put an arrow. And remember, this goes further in that direction. All right, so we're going to try another one. All right, so what can you tell me about this graph already?
The y will be negative.
The y values are going to be negative. It's going to be on the bottom side of your x-axis, right? All right, so go ahead and, like I said, I'd probably start with -1, 0, and 1 in your table and see what that gives you. And if you need more, either on the negative or the positive side, then add them in this graph. Kind of a general rule of thumb on these as far as what form your answer should be in is if you start with a fraction, then as much as possible, you might want to try, for just evaluating, try as much as you can to leave it as a fraction. If you start with a decimal, then your evaluating part is probably going to end up being a decimal. So whatever form you start with, is kind of, you want to stick with that as much as you can. Now we said this one should be on the lower side of the x-axis, right? Because that's negative. All right, so if I put in 0, that's an easy one to do. What do I get out?
Negative 0.5.
Okay, so that is going to be down a half. So if I do negative 0.5 times 2 to the negative 1, this ends up being negative 0.5 over 2. Hmm? Nope. What if you take, because that's a half, what if you divide a half in 2?
Oh, I multiplied for some reason.
4?
A fourth. So it's negative 0.25, right? Because you're doing negative 0.5 divided by...
How do you figure that out?
That, like I said, if you have a decimal, then you could either change this to a half, and then half of, when you move that 2 down, it's going to be 2 2s on the bottom. But if it's a decimal, yeah, I mean your final answer is going to be negative because you're taking negative 0.5 divided by 2. If you start with a decimal, then let your calculator do it for you. If you start with a fraction, we'll do one of those. But if you start with a fraction, then we try and keep it as a fraction if we can. So we'll do one of those also. But this is going to be negative 0.25. And then this one, negative 0.5 times 2 to the first. So that's a half, right? If you double it, that's 1, but it's still negative, yes? So this is negative 1. And can you tell by looking at these, you probably are going to want another positive. Negative 1 is not very far from the x-axis. So let's put in 2. So negative 0.5 times 2 squared is negative 0.5 times 4, which should be negative 2. Yes? All right, so if you go negative 1, we're at negative 1/4. 0, negative 1/2. 1, negative 1. 2, negative 2. And see how you're starting to see that curve now?
Yeah.
Just because if you do 3 that are very close together and they're looking linear, remember these are not linear. So
I'm going the wrong way, I think.
negative 1 would be over here.
Oh. That's not what my negative 1 was.
Yeah, remember the first value tells you right or left. And the second value tells you up or down. And all of these should be down. Okay, so does that follow what I had you guys write down? 2 is bigger than 1, so it's going to get further away from the x-axis. Your A is negative, so it's going to be on the lower side of the x-axis. So you should be able to tell from these, just looking at the function, what they're going to look like.
I'm still going the other way. It's confusing.